y equals to 1. So the same goes for the inverse matrix. Now let me show you another example. This time it involves a matrix 3 by 3 where we are given 3 equations. So the first step is to convert these equations into the matrix equation of AX equals to B. So before we could do that, we need to arrange these equations, alright, so that the X will be the first terms, and then followed by Y and followed by Z. So from here, we notice that X is the multiple of X is equals to 1. So we will write down 1, and then Y is 4. So we write down 4, and Z, the multiple is 1. Z here 1. So we write down 1. So the next equation, we do not have X. So therefore we will write it as 0. And then Y, we have 2Y. We will write as 2. We don't have Z. So therefore we will substitute Z with 0 here. And then the next equation, we have 2x, so the multiple is 2, we will write down 2, and then multiple of y is negative 3, we will write as negative 3, and 3z multiple is 3, so we will take up 3, and then followed by x, y, z. And on the right hand side, we will take 1, 3, 0 as the matrix for B. So that is step number 1. And step number 2, as usual, we have to find the determinant of the matrix A, which we have obtained just now. So, in order to find the determinant of A, which we have done, I would request you to refer slide number 28. So we have actually the determinant of A is equals to 2. Now next, we will proceed to find the minor of A, right? In the matrix 3 by 3 we have minor, so we have to find the minor of A. So from slide number 32 we actually have found the minor of A is equals to this. Then step number 4 is to find the cofactor of A, which we have already done earlier. Please refer to slide number 32. The cofactor of A is actually equals to this. And then step number 5 is to find the adjoint of A. And this also we have done. Please refer to slide number 33 earlier. The adjoint of A is this. Okay? And then step number 6 will be to find the inverse matrix of A. And this we have done earlier. Please refer to slide number 33. The inverse of A is this. So from here, to solve the equation, what we'll do is to use the formula x, y, z equals to the inverse matrix of A times matrix of B, which is 1, 3, 0. So I'm going to show you how to do it. So to find x, y, z, so this is the inverse matrix of A times 1, 3, 0. So remember, we have to use row times column. All the elements in a row times column, we will get this. The second row times column, we will get this answer. And then the third row times this column, we will get this answer. So it will be simplified. So this will be the answer for the question. So from here, we can say the value of x equals to negative 19.5. And then we have y equals to 1.5. And the same goes for z. We have the answer 14.5. So that is the method we use to solve a simultaneous equation, whether it is matrix 2 by 2 or 3 by 3. 2, therefore negative 1 minus negative 2 equals to 1. So repeat the same steps with A21, you should get 4, A22 is 1, and then A23 equals to negative 3, and then we have A31 equals to 2, A32 equals to 0, and finally we have A33 equals to negative 2. Now write down the whole answers as one matrix, which is the minor of A. So this is the answer. And next step is to convert this matrix to cofactor. So in order to do that, take minor A times the sign. Alright? So in this case, Negative 2 times positive, you get negative 2. 1 times negative, you get negative 1. 1 times positive is positive 1. 4 times negative equals negative 4. 1 times positive is 1. Negative 3 times negative equals to positive 3. Then we have 2 times positive equals to 2. 0 times negative 0. Negative 2 times positive will give us negative 2. So that is the cofactor of A. Alright? Step number 5 is to convert the cofactor to adjoint. So in order to find adjoint of A, we do a transposition on cofactor A. So remember, to do a transposition, all the elements in a row, you convert it into columns. Alright, columns to row and row to column. So from here, negative 2, negative 1, 1 becomes column. And then negative row 2 becomes column 2, and row 3 becomes column 3. So that is the adjoint of A. So step number 6 is to find the inverse of A using the formula 1 over determinant of A times the adjoint of A here. So we have found earlier the determinant of A equals to negative 2. So therefore we will take negative 1 over 2 times all the elements in the adjoint A. So from here we will get negative half times negative 2 equals to 1, negative half times negative 4 equals 2, negative half times 2 equals negative 1, negative half times negative 1 equals to half, and so on. So this is the inverse of A. So finally, to solve the equation, alright, so we will use the formula x, y, z equals to the inverse of matrix A times matrix B, which is 6 to 6. So from here you take row times column. So we will get 1 times 6 equals 6, 2 times 2, 4, negative 1 times 6 equals to negative 6, half times 6 equals 3, negative half times 2 equals negative 1, 0 times 6 equals 0, and finally the third row, negative half times 6 equals negative 3, negative 3 over 2 times 2 equals negative 3, and 1 times 6 equals 6. Simplify 6, eliminate with negative 6, remain 4, 3 minus 1 equals 2, and negative 3 and negative 3 will give us negative 6 plus 6 equals to 0. So therefore, the answer for x is equals to 4, y equals 2, and z equals to 0. So with that, I hope you are able now to answer assignment question number 2. Good luck.